ಜೀವನ ಹಿಂಗೆ ಕಳಿಸ್ಬಿಟ್ಟೆ ಸರ್ ಆಮೇಲೆ.
ಅದೇ ಬೆಟರ್. Hello. There is a. Hello everyone. We will continue motion in one dimension. Today we will solve some problems on graphs. Okay. So we have seen the basics of graphs now. On those only we can continue solving some problems. Okay. So just to refresh what we have studied, there are graphs, XTVT and AT graphs. So main points we understood: slope of XT graph, XT graph gives average velocity, slope of VT graph gives average acceleration, correct? So in a XT graph we studied V is equal to tan alpha something. Here A is equal to tan theta. Correct? These formulas also hold good. Okay? Clear? Next, area under VT graph. Area under velocity time graph gives what? Displacement. This also we have proved. Velocity time graph. I hope all of you understanding what we have studied the last class. I am just trying to refresh because we are going to solve at least 2 problems, 2 or 3 problems on this. Okay. Next, area under AT graph gives change in velocity. ಇದನ್ನು ನೋಡಿದ್ದೇವೆ. AT ಗ್ರಾಫ್ ಇದೆ, ಏರಿಯಾ AT, ಚೇಂಜ್ ಇನ್ ವೆಲಾಸಿಟಿ V minus V naught. ಇಲ್ಲಿ velocity is displacement by time. So displacement delta x is V into delta t. V into delta t is the area under VT graph. Clear or not? So this is what we have seen in the last class. Okay. These are the important points. Also we have seen 9 to 10 graphs, but out of that these are more important for your competitive exams, whether it is CET, NEET or JEE. These factors must be used more often. Okay. Now write down a problem. We'll solve based on these. An object starts from rest and has acceleration changing with the time, acceleration changing with the time as shown in the graph. Maximum velocity of the object is object is. So the graph shown is the acceleration time graph. Okay, this is acceleration and time t. This is acceleration. This is how the graph is shown. Acceleration is changing with the time now. Okay, is that clear? Now this is 5. This is 6. Okay, time is 6 seconds and acceleration is 5 meter per second. Initially the acceleration was 5 meter per second, then it started to decrease gradually. And it becomes 0 at the 6th second. Then maximum velocity of the object is, your options are 5 meter per second, option B 10 meter per second, option C 15 meter per second, option D 30 meter per second. How to solve this problem now? A T graph, and they have asked us to calculate change in velocity, or rather maximum velocity. They have asked us to calculate maximum velocity. So how to do it? Any doubt? Any ideas? See, idea is based on the graph only you need to do. That is why graph is given. Solution is area under VT graph. Sorry, this is our acceleration time graph. No, area under AT graph gives change in velocity. So this is the area now. This should be the marked area which gives us a triangle. No, this gives us a triangle now. So area of the triangle is half BH should be equal to V minus V0, where V0 is the initial speed. Athwa V minus U baridi, tondre illa. V minus U is the initial velocity. So half, what is base? Base is 6, height is 5, V, initial speed, object starts from rest and when it starts from rest, initial speed is 0. Initial speed is 0. So this is 30 by 2 is the maximum speed, which is 15 meter per second is the right answer, which is option C. Clear? So acceleration changes with the time, no? That is why AT graph, had it been constant, it would have been a rectangle. Here acceleration is changing with the time. See, had it been a rectangle, this one, straight line where acceleration is constant with the time, then we would have got the rectangle. That time we would have multiplied simply 5 and this is 6. 30 would have been answer then had the acceleration been constant. Now acceleration is changing with the time, no? Gradually changing with the time. So we take the average of change. Average change we take. That is why obviously it forms a triangle. Otherwise average change we can take it as instead of BH, half BH we can take, or that forms a triangle. That way. In any way you can look at it. That is why the answer should be 15 meter per second. Hope everybody understood this. Okay? Shall I wrap this now? Completed? Next, a lift starts from rest its acceleration time graph is as shown. Distance traveled by the lift is, so this is the acceleration time graph now. This is acceleration, here 2, acceleration time graph, here 4, distance traveled by the lift. Okay, this is okay. This is time graph T. In lift, in 6 seconds of the method, distance traveled by the lift in 6 seconds is acceleration time graph, and this is -2. Yes, try this. See, to find the distance, I have to have area under VT graph. This is the acceleration time graph. That is why this acceleration time graph must be converted into velocity time graph. So here it is a tricky problem. Here acceleration time graph must be converted first into velocity time graph. Very important, velocity time graph. So, note the same timing diagram I will take. This is 4 seconds. This is 2 seconds. So what I'll do, I'll draw a graph. This is 2 seconds, 4 seconds, 6 seconds. Is that clear? The lift starts from rest and ಹೇಳಿದ so its initial speed should be 0. Okay, its initial speed should be 0. So at the end of 2 seconds its speed should be v. So that is velocity time graph. No, its speed should be v. So at t is equal to 2 seconds, v is equal to u plus at. Throughout these 2 seconds, acceleration is constant. So it should be 0 plus 2 into 2 seconds. V should be 4 meter per second. V should be 4 meter per second. So it is not sudden increase. It is a gradual increase to 4 meter per second. 4 meter per second is the velocity now. Clear? At the end of 2 seconds. Because initial speed is 0 as it starts from rest. Since acceleration is constant throughout, for a constant acceleration, this equation I can use. This equation is valid, kinematic equation. Correct? Okay. So, at the end of 2 seconds, velocity is 4 meter per second. Here now, acceleration is 0 means velocity should be constant. That's all. Between 2 to 4 seconds. Between 2 to 4 seconds, velocity should be constant as acceleration is 0. So it should remain 4 only. It should remain 4 only. Are you following? Since there is no acceleration between 2 and 4 seconds, it should be constant velocity. Velocity should not change. Whatever the velocity that was there at the end of 2 seconds should be the velocity at the starting of the 3rd second and at the end of the 4th second also. Now coming to the 4th second, acceleration becomes -2. From 4 to 6 seconds, acceleration is -2. But 4 to 6 seconds, it is constant again. That is why for a time interval of t is equal to 4 seconds to 6 seconds. ಏನಾಗ್ತದೆ ಇದು? v is equal to u plus at. ಈಗ the velocity at the end of 4 seconds is a initial velocity for the 5th second. Agree? Velocity at the end of 4th second is the initial velocity for the starting of the 5th second. That is why I'll write this as u2, this will become u2, this will become a2. So, final velocity I need to calculate. This is 4 plus a2 is -2, no? -2 for 6 minus 4 seconds. So v2 will be 0. Final velocity at the end of 6th second will be 0, like this. Understood? Any doubts? Understood the graph? Is our problem over? No, not yet. Any doubt regarding this? Clear? Okay. All of you have a look here. Now, listen to me. This is a velocity time graph I got, no? Now we know distance traveled So this is the speed time graph. Distance traveled is area under VT graph. See, there is no negative value, only positive, no here. So you can consider this as magnitude of velocity speed also. Okay. So area under VT graph. So what is the area now? This is area 1. area 2, area 3. So now half, base is 2, height is 4, correct? Plus rectangle now. Rectangle is 4 into 4 minus 2. That is the second area. Is it visible if I write there? Yeah, the step is just visible. Okay. 4 into 4 minus 2 plus another half. Base is 6 minus 4. Height is 4. Okay, now you calculate. Here half and 2 cancels off. This also half and this is 2 cancels off. So distance traveled is equal to 4 plus 8 plus 4. So which is 16 meter. This is the distance traveled. 16 meter is the answer. Understood? Okay, such problems you can solve. Hope you know why to convert AT graph into equivalent VT graph, because we want to find the distance. Distance is area under VT graph. That is why acceleration time graph must be smartly converted into velocity time graph. Must be smartly converted into velocity time graph. Is that clear? Can I rub this off? To try such problems, you can find it elsewhere. These graphical problems are always very nice to solve. Okay. Next, an object moves as shown in the graph. Distance traveled and displacement R. Distance traveled and displacement R. So see here, This is a velocity time graph where this is 3 seconds, this is 6 seconds, this is 9 seconds. This is also minus 3 meter per second. Now what is the distance traveled and displacement? This is 6 seconds and this is 9 seconds. Yes, you try this. This is comparatively easy. Distance and displacement at the end of 9 seconds. At the end of 9 seconds are yes, try this problem. Yes, see here, velocity is positive, no? So, area we have to think of. For displacement is area under VT graph. Area under VT graph. That is, what is the area here? L. This is the area, rectangular one. Correct? Rectangular one. So, if you just imagine how the vehicle is moving now, it is moving with constant velocity for 3 seconds. Then its velocity becomes 0. That means it will stop. Then what happens? It comes back. No, reverse velocity. Velocity negative means it is coming back. It is coming back. That's all. So this area also you have to take into consideration. Coming back. So common sense wise, 3 meter per second, in 3 seconds it will move 9 meter. Then next minus 3 into 3. Minus 9 meter it will move back, displacement should be 0. Suppose if you do that here, area under VT graph, 3 into 3, there is no area here, this is the area covered by VT graph, this is the VT graph, area covered by VT graph is plus minus 3 into 9 minus 6, so this is 9 plus minus 3 into 3, 9 minus 9, 0 should be the displacement. 0 should be the displacement. Is that clear? Next, they have asked the distance now. Distance is the total path length traveled. No. So how the body would move? From here it will start and here it will end. Again from here to here it will move. No. Here, how the? From here it will start, then again here it will end. Hope you understand. Okay? So distance is total path length, no. And speed is only positive, there is no negativity regarding speed. It is only positive. Total path length will be counted on, whether you are going forward or coming back, the total path length will be simply added on. So 9 meter ಮುಂದೆ ಹೋಗ್ರಿ, 9 meter ಹಿಂದೆ ಬಂದ್ರಿ, total path length traveled by you is 18 only. Correct? So distance is 3 into 3 plus 3 into 9 minus 6 ಅಷ್ಟೇ. ನೆಗೆಟಿವ್ ಸೈನ್ ತಗೊಳ್ಳಿಕ್ಕಿಲ್ಲ. ಇದು ವೆಲಾಸಿಟಿ, ಇದು ನೆಗೆಟಿವ್ ಸೈನ್. ಸ್ಪೀಡಿಗೆ ಆಗುವಾಗ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ವಾ? ಡಿಸ್ಟೆನ್ಸ್ ಬೇಕು ಅಂದ್ರೆ ಸ್ಪೀಡ್ ತಗೊಳ್ಬೇಕು. ಸ್ಪೀಡ್ ಇಸ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ದ ವೆಲಾಸಿಟಿ. ಸೊ ಇಟ್ ಶುಡ್ ಬಿ 18 meter. 9 plus 9, 18 meter should be the answer. I hope you understand the difference at least now. What is displacement and what is distance? Vehicle has traveled 18 meter of distance. But once it returns to its original position, its displacement becomes 0. Clear? I hope all these graphical problems will help you to understand the problems and concepts much better. Okay? So okay, next we shall find expressions for average speed. Average speed. There are two cases. Average speeds or average speed, mainly it undergoes, it has two cases. See, average speed is obviously given the definition before. Average speed is total distance traveled divided by total time taken. Total distance traveled divided by total time taken. Total time taken. Okay. Now, ಇದು general definition. This is a general definition of average speed. Now, consider case 1 where you consider an object moving with the speed v1 for time t1 for 1/2 of the distance, with speed t1 for 1/2 of the distance, for 1/2 of the distance, and with the speed v2 for time t2 for the next half. Then the average velocity of the journey is V average is equal to what? We have to find. You write down this first. Understand this now. See, any doubts? Okay. An object moving with speed v1 for time t1 for 1/2 of the distance, and with the speed v2 for time t2 for the next half of the distance, for the next half, then average velocity of the journey. So ನೋಡಿ ಇಲ್ಲಿ total distance is from A to B, where there is a midpoint C. So A to C is 1/2 of the distance. C to B is the other half of the distance. From A to C, speed with which vehicle travels is v1. Time it takes is t1. From C to B, it travels with the speed v2 in time t2. In time t2. Is that clear? Now we will go by the definition. Our God-like definition it is. The basic definition, average speed is distance by total time. So, V average is, what is the total distance? S by 2? S by 2, which is should be S. Total distance should be S. Time taken is T1 plus T2. Total time taken. Agree? Now, listen to me. During EAC, what is the distance? S by 2. Straight line, it can be displacement also. So it is S by 2. S by 2 divided by time t1 is v1, no? Distance by time is velocity, right? Or speed, right? Agree? So that should imply S by 2 by v1 equal to t1. Similarly for path CB, what is the distance it travels? S by 2 with the time t2, then it should be the speed v2. That should imply S by 2 by v2 should be equal to t2. Should be equal to t2. Understood? Now you substitute for t1 and t2. Now you substitute. S by t1 is S by 2 by v1 plus S by 2 by v2. S by 2 by v2. That implies idenaagtade S by idu S by 2 1 by v1 plus 1 by v2. Clear? Yes. Now see here, that will be S and S cancels now. This 2 goes up now. Divided by V1, V2, I will take common denominator now. At the denominator only. This 2 will go up as it is a denominator of the denominator going to the numerator. V2 plus V1 is the average speed. So rearranging this, I can write V averages. Rearranging this, I can write V averages. This one obviously should go up. 2 V1 V2 divided by V1 plus V2. So from here on, when distances are made into equal halves, this is a formula for average speed. This is a formula for average speed. Is that clear? Write down fast. Next, we shall think of another case, second case. The definition of average speed remains the same even for that case also. ಇಲ್ಲಿ ಏನು ಕಲ್ತಿದ್ದು ನಾವು? When the distance is a equal half, average speed is a harmonic mean. Harmonic mean ಅಂತ ಹೇಳ್ತೇವೆ ಇದನ್ನ ನಾವು. Okay, so average speed, you might have studied in maths. What is harmonic mean? Geometric mean? What is arithmetic mean? Okay, so this is called a harmonic mean. Okay, so now we shall go to case 2. Case 2 we will study now. Case 2 we shall study so Barili, an object traveling with the speed v1 for time t and with the speed v2 for the next time interval of t seconds ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ for the next same time interval ಇಲ್ಲಿ first half distance ಅಲ್ಲ ಇದು, this is in terms of time now. So it will travel with the speed v1 for time interval t, 0 to t seconds it will travel with the speed v1 for next t seconds. ಅಂದ್ರೆ time ತಗೊಂಡ್ರೆ 0 seconds ಇಂದ t seconds ವರೆಗೆ speed v1, next t seconds ಇಂದ 2t seconds ವರೆಗೆ, ಆಗ time interval ಏನಾಗುತ್ತೆ 2t minus t ಆಗುತ್ತೆ, t2 minus t1 ಆಗುತ್ತೆ. So it will travel with the speed v2. Hope you understood. Time interval is t seconds. Okay? Time interval is t seconds. Initially it travels with speed v1 up to 1 hour t seconds. Other time t means 1 hour you take. For next 1 hour it will travel with the speed v2. Totally 2 hours it has traveled. But for first first 1 hour the speed is v1. For the next 1 hour the speed is v2. Then what is the average velocity? We have to see. So for that, if the speed is more, it will travel more distance, no? If the speed, you are on a highway for 1 hour, you can travel 60 kilometers. So this is S1. Sorry. Traveling with speed v1 in time t seconds. This is S2, small time, small distance traveled because velocity has decreased. Now we have reached the village road. Okay. So now V average of this also is total distance by total time only. Total time only. Now what is the total distance here? No acceleration. It is moving only with constant velocity. So S1 should be V1t, S2 should be velocity into time, V2t. So this should be V1t plus V2t divided by T1 is also T, T2 is also T. So it should be V1 plus V2, if I take common, then it is 2T, TT Tata. Okay, so V average is V1 plus V2 divided by 2. This is the arithmetic mean. We call this as arithmetic mean. So average velocity can be calculated in two ways. A harmonic way mean when the distance is divided into equal halves of the whole journey's distance, divided into one half with the speed v1, another half traveled with the speed v2, then the equation becomes 2v1 v2 divided by v1 plus v2. Here distance is not equal, time interval 2 hours of journey, in 1 hour you travel with the speed v1, in next 1 hour you travel with the speed v2. Then arithmetic mean should be used. When time intervals are equal, average velocity is arithmetic mean of the two velocities. When distances are made into equal halves, it is a harmonic mean. Is that clear? It is a harmonic mean. Hope you understood all of you today. Any doubts? Completed? Completed writing it down? Okay, we shall continue now. I'll tell you how to solve these problems. Write down, a car moves from A to B at a speed of 30 kilometer per hour and returns to A from B at a speed 20 kilometer per hour. Average speed of the journey is answers are 24 kilometer per hour, 12 kilometer per hour, 25 kilometer per hour and 18 kilometer per hour. This is first question. Second one, shall I give you or solve it? Better to solve it. Try to solve this now. Think of the formula, try to solve it. Or I'll give you one more question, then probably you will understand why it is different. An automobile maintains a speed of 80 kilometer per hour for 1 hour, and in next 1 hour it travels with the speed 40 kilometer per hour. What is the average speed? What is the average speed of the journey? Average speed of the journey. A, that is 60 kilometer per hour. B, 120 kilometer per hour. C, 45 kilometer per hour. D, 32 kilometer per hour. So there are two questions. How to solve them? So here in the second one, the time intervals are same, no? 1 hour and next 1 hour is said. So time intervals are same. That is why I will use the formula V average is V1 plus V2, and there are two velocities, so I have to take arithmetic mean. V1 plus V2 divided by 2. So it should be 80 plus 40 by 2. 60 kilometer per hour. It should be 60 kilometer per hour. Clear? So option A is the right answer. Option A is the right answer. Then what about the next problem? A car moves from A to B at a speed of 30 kilometer per hour and returns to A from B at a speed of 20 kilometer per hour, average speed of the journey should be. See here, a car moves from A to B, a distance let it be S. Car moves from A to B because speed 30 kilometer per hour speed, no. Then it returns to A from B. Again it travels a distance, yes, no. Again it travels a distance, yes, only. Correct? Yes, many of you have answered. First one, 25, somebody has answered. Second one, okay, very good. Sanjana, first one is very good. Correct answer. Aditya and Priyanka have answered for the second one. Correct. Very good. See, this is forward journey distance. It is return journey distance. If you take the total distance, it is 2s. Forward journey distance is yes, return journey distance is yes. So forward journey distance is a half of the journey distance. Return journey distance is half of the journey distance. That is why I can use the formula 2v1 v2 divided by v1 plus v2. Because when the distances are equal, halves no. So forward journey distance is one half. Return journey distance is the other half. So it should be 2 into what is v1 30. v2 is 20 divided by 30 plus 20. So it should be what is this? 20 into 30, 600,000, 200 divided by 50. So it is 24 kilometer per hour, not 25. A is the correct answer. A is the correct answer. I hope you like trying such problems in whichever book you have. Okay? Try to find such problems. Okay? So that we can solve many problems. In the next session we will go to motion under gravity. That is very interesting. Motion, when you throw the ball upwards, how it is going to come back. All those things we will solve. Okay. That will be very interesting to study. So thank you so much for your patience listening. Okay, thank you.